Hello students, I Jairam Moar, Senior Lecturer. I welcome you all for the program Jnana CET NEET coaching classes for engineering and medical entrance exams conducted by Department of Pre-University Education, Government of Karnataka. Today I am going to discuss two chapters for CET and NEET coaching questions. So they are general principles and process of isolation of elements. The second one is 15th group elements or nitrogen family. So first of all, so let us see the synopsis present in the first chapter, general principles and process of isolation of elements. Elements are the basic units of all types of matter. They are found to occur in nature either in the free state or in the combined state. So there are two types, native state or free state. Elements which are not attacked by moisture, oxygen and carbon dioxide of the air are occur in free state. For example, gold, platinum, noble gases, etc. Combined state, elements which are attacked by moisture, oxygen and carbon dioxide present in the air occur only in the combined state. For example, CuFeS2, Fe2O3, Fe3O4, etc. Let us see the next one, minerals. Elements which occur in the combined state in the form of their compounds are called minerals. Ores. The minerals from which metal is extracted conveniently and economically is called ore. So ores are present in different forms. Hence, they are also known as different types. They are oxide ores. For example, bauxite. The composition of bauxite is Al2O3 dot 2H2O. It is a chief ore of aluminium. Hematite, its composition is Fe2O3. It is a chief ore of iron. Magnetite, composition is Fe3O4. It is also the chief ore of iron. Pyrite, composition is Cu2O. It is a ore of copper, but it is a low grade ore. The next one is ginsite, composition is ZnO, chief ore of zinc, etc. Sulfide ores. Copper pyrite is CuFeS2. It is chief ore of copper. Copper glans, composition is Cu2S. Zinc blende, ZnS. Fool's gold, FeS2, etc. All this contains sulfur as impurity, hence they are called sulfide ores. The next type of ores is carbonate ores. Siderite, FeCO3, it is a carbonate ore of iron. Calamine, composition is ZnCO3, it is a ore of zinc, etc. So these are called carbonate ores because they contains carbonate as impurity. Let us see the meaning of metallurgy. So the process of extraction of metals from their ores is called metallurgy. So metallurgy has the following steps. They are called metallurgical process. They are, the first one is concentration or beneficiation of the ore. So concentration meaning it is the removal of gangue or matrix. Gangue or matrix is nothing but the rocky and earthy impurities present in the ore are called gangue or matrix. So it is done by the following methods. The first one is gravity separation, or it is also called levitation. The second one is froth flotation method. The third one is magnetic separation method. The fourth one is leaching. It is the process of dissolving ore with acid or base or other chemicals, but not the impurities. The next one is next step is conversion of concentrated ore into metal oxide. It is done by the following methods. The first one is calcination. In this method, ore is heated in the absence of air or limited supply of air below the melting point of the metal. For example, carbonate and hydroxides on heating in absence of air loses moisture, and also they are loses carbon dioxide and converted into metallic oxides. For example, CaCO3 on heating in the absence of air, it is converted into CaO plus CO2. So in this one, the carbonate ore is converted into oxide of the metal. Similarly, Al2O3 dot 2H2 on heating converted into Al2O3 plus 2H2O. So in carbonate method, the oxide, hydrated oxide and carbonate ores are converted into respective oxide ores. So let us see the next one, roasting. In roasting, ore is heated in excess of air below the melting point of metal. Example, sulfide ores, for example, Cu FeS2. Copper pyrite is on heating in excess of air, it is converted into Cu2S plus 2FeS plus SO2. So in this method also, sulfide ore is converted into, so its oxide form. Or let us see another one, ZnS on roasting with excess of oxygen converted into zinc oxide plus SO2. So hence in roasting method, sulfide ores are generally converted into their oxide ores. In chalcopyrite also, cuprous sulfide again burns with oxygen, converted into cupric oxide. Similarly, ferrous sulfide again burns with oxygen, converted into FeO. That means sulfide ores are generally converted into oxide ores in this method. Let us see the next one, next step in the metallurgical process, extraction of the crude metal from the concentrated ore. It is done by the following method. The first one is smelting. It is the process of extraction of a crude metal by using reducing agent, coke or carbon monoxide at high temperature is called smelting. For example, so zinc, iron, tin, lead, etc. are obtained by this method. The second one is self or auto reduction. It is the reduction of metal oxide on their own without the use of external reducing agent is called auto reduction, or it is also called self reduction. For example, mercury, copper, Pb, etc. undergoes self reduction to their respective metals. They are called crude metals. The next one is flux. It is a substance used to remove impurities present in the crude metal. Generally, it is used in smelting process. For example, that is flux plus gangue gives a slag, means flux combines with the impurities, acidic impurities or basic impurities present in the molten metal, gives easily fusible mass called slag. For example, SiO2 is acidic flux used in the removal of FeO present in the molten copper metal. Likewise, CaO acts as a basic flux in the extraction of pig iron. The CaO combines with the impurity SiO2, giving rise to CaSiO3. That is, so in copper extraction, so SiO2 is acidic plus, combines with FeO, giving rise to SiO3, ferrous silicate slag. Similarly, in the extraction of iron, the impurity SiO2 combines with CaO, giving rise to CaSiO3, that is calcium silicate slag. Now let us see the next last step in the metallurgical process, that is refining of the crude metal. So after the crude metal is obtained, still it contains some impurities. The removal of these impurities from the crude metal is known as refining of the crude metal, or it is also called purification of the crude metal. For example, the process of purifying the crude metal is called refining. It is carried out by the following methods. The first one is zone refining. Example, ultra pure silicon and germanium is obtained by this method. The second one is distillation. So in this method, zinc, mercury, cadmium are obtained in pure state because these are all volatile metals. The next one is liquefaction. In this method, tin and lead are obtained in pure form. The last one is vapor phase refining. So the principle in the vapor phase refining is it involves the conversion of metal to volatile compound and its decomposition at high temperature to get a pure metal. Example, nickel is obtained in pure state by Mond's process. Titanium and zirconium are obtained in pure state in Arkell method. So now let us see the synopsis regarding group 15 elements. Nitrogen, phosphorus, arsenic, stibbium and bismuth are called 15 group elements, and the valential electronic configuration of all these elements is NS2, NPX1, NPY1, NPZ1, means they have 5 electrons in their outermost shell. So the next first element in 15 group elements is nitrogen. It forms p-pi multiple bonds by weaker van der Waals forces and present as diatomic gas molecule, that is N2, due to its small size and high electronegativity. So it is less reactive at room temperature, whereas phosphorus exists as a tetrameric molecule, that is tetrahedron, means 4 atoms are combined in the form of tetrahedron and forms only single bonds. Let us see the oxidation state of some of the elements present in the 15 groups. Nitrogen exhibits oxidation state from -3, -2, -1, 0, +1, +2, +3, +4 and also +5. Means it exhibits all the oxidation states from -3 to +5. Likewise, phosphorus. Phosphorus has the following oxidation states: -3, -2, 0, +3, +5. Arsenic, stibbium and bismuth shows only 3 oxidation states, +3 and +5. Due to inert pair effect, stability of +5 oxidation state decreases and +3 oxidation state increases. That means as we move down the group from nitrogen to bismuth, the participation of inner s electrons not involved in chemical bonding. Therefore, the oxidation state becomes +3, hence it is more stable. Let us say hydrates of the group shows the following trends. The first one is bond angle. Ammonia is greater than PH3, is greater than arsenic hydride, greater than SbH3, is greater than BiH3. This is due to increase in size and decrease in electronegativity of the central atom. So, as we move from top to bottom in the same group, the atomic size of the elements increases. This is because a fresh electron is added to new principal quantum number. Hence, the size of the nitrogen, phosphorus, arsenic, strontium, bismuth increases. Hence, the bond angle goes on increases. The next property is basic character. So, regarding basic character, the basicity of ammonia is always greater than the basicity of phosphine, PH3. This is because as the size increases, electron density of the central metal atom decreases. So, the size of the phosphorus atom is more than the nitrogen atom. Therefore, electron density on the nitrogen atom decreases. Hence, phosphine is less basic than ammonia. So, now let us see oxides of nitrogen. So, nitrogen forms 5 oxides. They are nitrous oxide, known as laughing gas. The next one is nitric oxide. So, it is odd electron oxide. The next one is N2O3, dinitrogen trioxide, nitrogen dioxide, dinitrogen pentoxide. Their acidic strength increases in the order N2O, NO, N2O3, NO2, N2O5. This is because the oxidation state of the nitrogen atom increases from N2O to N2O5. Hence, their acidic strength also increases. So, hence N2O is called laughing gas. It is paramagnetic in gaseous state due to the presence of an odd electron. Next property, all these elements form trihalides, formula EX3, and pentahalides EX5. So, among them, NF3 is not undergoes hydrolysis and exothermic compound. Hence, it is explosive. The next one is PCl5 is covalent in vapor phase, but exists as a PCl4 plus ion and PCl6 minus ion. So, let us see the next point, oxoacids of nitrogen. Nitrogen forms 2 oxoacids. The first one is HNO2, known as nitrous acid. The second one is HNO3, known as nitric acid. So, nitric acid is manufactured by Ostwald's process using ammonia and dioxygen by the catalyst platinum rhodium gauge. It acts as strong oxidizing agent both in concentrated and dilute form. So, with copper, silver and mercury, which are less reactive than hydrogen, reacts with concentrated HNO3 forming nitrogen dioxide gas, and with dilute HNO3 nitric oxide is formed. Whereas platinum, gold not reacts with concentrated HNO3 but reacts with aqua regia. So, aqua regia is a mixture of 1 part concentrated HNO3 and 3 parts concentrated HCl. Now, let us see the next element, phosphorus, present in 3 allotropic forms, white, red and black phosphorus. Phosphorus white is poisonous, soluble in carbon disulfide but insoluble in water. It is more reactive due to angle strain. It forms PH3 with NaOH and water. It forms 2 halides, PCl3 and PCl5. Next point, it forms 2 oxides, P2O3, or it is also known as P4O6, that is phosphorus trioxide, and P2O5 called phosphorus pentoxide, its dimer P4O10. So, it acts as a dehydrating agent, means it removes water. So, in some of the reactions, hence it is called dehydrating agent. Now, let us see oxoacids of phosphorus. Phosphorus forms several oxoacids, among them H3PO3, hypophosphorus acid, it is monobasic due to one OH bond, and it acts as strong reducing agent due to the presence of two pH bonds. H3PO3, another oxo acid of phosphorus, it is dibasic because it has two OH groups in its molecule. The next one is H3PO4, phosphoric acid. It has three OH group, hence it acts as a tribasic. The next one is cyclometaphosphoric acid, means HPO3 thrice, it is tribasic. The next one is pyrophosphoric acid, H4P2O7, it has four OH group, hence it is tetrabasic. The next one is pyrophosphorus acid, the formula is H4P2O5, it is dibasic due to the presence of two OH groups. The next form of phosphorus is red form, it is non-poisonous, whereas white phosphorus is highly poisonous, but red phosphorus is non-poisonous. White phosphorus is insoluble in water, but red phosphorus is insoluble both in water and CS2. It forms only P4O10 on heating with air, but it does not form P2O3. So now let us see the CET questions based on CET and NEET questions based on above concepts. The first is on general principles and isolation of elements. The first question is, the metals which occur in native state are, the options are AU, that is gold, PT platinum, option B zinc, magnesium, option C sodium, iron, option D aluminum and lead. So as I already gave you the hint regarding this one, those metals which are non-reactive with air, moisture and carbon dioxide occur in native state. So here, AU and platinum are less reactive. They are not attacked by carbon dioxide, moisture of air. Yes, they occur in a free state. Therefore, option A, because AU and platinum not attacked by oxygen, moisture or carbon dioxide present in the atmosphere. But other metals like zinc, magnesium, sodium, iron, aluminum and lead, etc. reacted with oxygen, moisture or carbon dioxide present in the atmosphere. Therefore, they will not occur in native state. So now let us see the second question. The most abundant metal and element in the earth crust are, the options are aluminum and nitrogen. The second option aluminum dioxygen. The third option iron hydrogen. The fourth option calcium and oxygen. So to know this one, most abundant metal and element, let us see the percentage of elements in the earth crust. Aluminum occurs to an extent of 8.32%. It is the largest percentage of the metal which occurs in earth crust. And the second one is oxygen, 46.4%. The remaining elements, iron occur to an extent of 5.63%, calcium 3.6%, dihydrogen 0.14%. Therefore, the most abundant metal in the earth crust is aluminum, and most abundant element in the earth crust, not in the atmosphere, it is in the earth crust, is aluminum and oxygen. The option is B, Al and O2. So now let us see the third question. The third question is, the chief ore of copper is. So copper occur in different forms of ores. The options are bauxite, the second one is hematite, the third one is chalcopyrites, the fourth one is cinnabar. So here chief ore of copper is asked, Copper occurs in different forms, as I already told you. The first form is sulfide form, CuFeS2, and next one is Cu2S. Cu2S is called a low grade ore. Hence, most of the copper is not extracted by this ore. A majority of copper is extracted by its chief ore, chalcopyrites. Hence, the option C is correct. The first option A is not correct because bauxite is a ore of aluminium. The second option is also not correct. This is because hematite is a ore of iron. Its composition is a Fe2O3. The last one is cinnabar. So, cinnabar composition is HGS. It is a ore of mercury, not the ore of copper. Hence, the correct option is chalcopyrites. Its composition CuFeS2. So, fourth question, malachite is an ore of, options are, the first one is silver, the second one is mercury, the third one is magnesium, the fourth one is copper. So, malachite is also called malachite green. So, for which one it is ore? Let us see. So, the composition of malachite green is CuCO3 dot CuOH twice. So, here copper is present in both the forms. The second, mercury. So, the ore of mercury is cinnabar. Its composition is HGS. The ore of magnesium is KCl MgCl2 dot 6H2. Therefore, so the copper present in malachite, that is in CuCO3 dot CuOH, therefore, malachite is a ore of copper. Now, let us see the next one, next question. Which one of the following is not a method of concentration of ores? So, as already told you that concentration is nothing but the removal of rocky and earthy impurities present in the ore. So, it is done by different methods. The options, the methods are given in the options. The first one is gravity separation, the second one is froth flotation method, the third one is electromagnetic separation, the fourth one is smelting. So, gravity separation method is used to concentrate oxide ores. So, this is based on the difference in the densities of ore and the gangue particles. So, now let us see second one, froth flotation method is used for the concentration of sulfide ores. So, this is also based on the difference in the wettability of ore particles and the gangue particles with oil and water. The next one is electromagnetic separation. This difference is, if the ore or the gangue particle is magnetic in nature, then this method is used. The next one is smelting. Smelting is not a concentration method. Therefore, so answer is D. It is used to obtain crude metals from concentrated ores, but it is not a concentration method. So, the question is asked here is, which one of the following is not A? Is not A. Here not is given. So, therefore, smelting is not a concentration method used to concentrate ores. Hence, option is D. Now, let us see the next slide, the sixth question. Usually, oxide ores are concentrated by gravity separation method, which is based on the principle. The four options are given here: difference in the wettability of ore particles in oil and water. The second option is difference in the specific gravities or densities of the ore and gangue. The third option is difference in the magnetic properties of ore or gangue. The fourth is difference in the particle size of ore. So, the question is asked here on the gravity separation. The principle in the gravity separation method is difference in the specific gravities or densities of the ore and gangue. Therefore, option is B. It is a correct option. The other three options are not correct. This is because the first one is used in a froth flotation method. The third one is used in electromagnetic separation. The fourth one is a general. It is not applicable to any method. Let us see the next one. Seventh question. The role of pine oil and potassium ethyl xanthate in the froth flotation process is to enhance the non-wettability of. The options are first one, mineral particles in froth, B, mineral particles in water, C, gangue particles in froth, D, gangue particles in water. So, ಈ ಕ್ವಶನ್ ಅಲ್ಲಿ ಏನು ಕೊಟ್ಟಿದ್ದಾರೆ ನೋಡಿ, the role of pine oil and xanthates in froth flotation process to enhance the non-wettability of. So, in froth flotation process, the powdered ore is mixed with water and oil, even froth stabilizers, and it is stirred well by passing air. So, in this method, the ore particles usually wetted by the oil and gangue particles are wetted by water. The ore particles which are wetted by the oil and xanthates carries these particles to the surface, and the gangue particles which are wetted by water become heavier, collected at the bottom. So, therefore, pine oil, xanthates, even fatty acids acts as collectors to enhance the non-wettability of ore particles with water. Similarly, in the same process, creosotes and aniline stabilizes the froth. So, hence it is separated correctly, and so it is degassed. So, but gangue are wetted by water. So, therefore, correct option here is B. Now, let us see the next question, 8th question. Sodium cyanide is added in the froth flotation process as a depressant when the ore contains a mixture of zinc sulfide and lead sulfide, because ಇಲ್ಲಿ ಎರಡು ಓರ್ ಮಿಕ್ಸ್ ಇದ್ದಾಗ ಅದಕ್ಕೆ ಸೋಡಿಯಂ ಸೈನೈಡನ್ನು ಹಾಕ್ತಾರೆ. ಸೋಡಿಯಂ ಸೈನೈಡನ್ನು ಹಾಕುವುದರ ಉದ್ದೇಶ ಏನು ಅಂತ ಕೇಳಿದ್ದಾರೆ. ಇದಕ್ಕೆ 4 ಆಪ್ಷನ್ಸನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. There are 4 options. The first one is PbCN2 gets precipitated without any effect on ZnS. The second option, ZnS forms soluble complex Na2ZnCN4 times, while PbS forms the froth. The third option is PbS forms soluble complex Na2PbCN4, while ZnS forms the froth. The fourth option, ZnCN twice gets precipitated without any effect on PbS. So, ಇಲ್ಲಿ NaCN ಅನ್ನು ಮಿಕ್ಸ್ ಮಾಡಿದ್ದಾರೆ. ಅದರ ಉದ್ದೇಶ ಏನು ಅಂತ. Here NaCN combines with ZnS gives sodium tetracyanozincate. That is 4NaCN plus ZnS gives Na2ZnCN4 times plus Na2S. So, this complex prevents the PbS from the formation of froth, but PbS forms froth. So, ಇದು ZnS froth formation ಅನ್ನು ಪ್ರಿವೆಂಟ್ ಮಾಡುತ್ತೆ, whereas so PbS froth ಅನ್ನು ಫಾರ್ಮ್ ಮಾಡ್ತದೆ. Therefore, it carries to the surface. Hence, NaCN acts as a depressant. The choice is ZnS forms soluble complex Na2ZnCN4 times, whereas PbS forms the froth. So, now let us see the 9th question. Which one of the following process is related with the removal of sulfur present in the ore by heating in the air? So, there are 4 options. The first one is smelting, the second one is calcination, the third one is annealing, the fourth one is roasting. So let us see one by one. Smelting is used to extract crude metals from the concentrated ores by heating to high temperature using a suitable reducing agent, coke or carbon monoxide. The second one is calcination. So it is the process of heating the ore in the absence of air. The next one is annealing. So annealing is used in cooling steel. It is not a concentration method. The next one is roasting. Roasting is defined as heating of the concentrated ore in excess of air below the melting point of the metal. So see the question. Which one of the following process is related with the removal of sulfur present in the ore by heating it in the air? So that means sulfide ore is concentrated by which method? So the method used here is roasting. So explanation is given and answer correct option is D. So in roasting, sulfur present in the ore is converted to sulfur dioxide, hence option D is correct. Now let us see the next question. In the extraction of gold and silver involves leaching the metal with cyanide ion. The metal is recovered by displacement of metal by zinc from the complex ion. B. Roasting of metal complex. C. Calcination followed by roasting. D. Thermal decomposition of metal complex. So once again let us see the question. Extraction of gold and silver involves leaching the metal with cyanide ion. The metal is recovered by. So in this method, gold and silver native ores are dissolved in aqueous solution of sodium cyanide and air. So hence it forms a complex. From the complex, the gold or silver is displaced by adding zinc. So here zinc acts as a reducing agent. Therefore, the correct option is displacement of metal by zinc from the complex ion. So other three options are not correct because roasting is a concentration method, it is not a displacement method. Calcination is also not a displacement method, it is also concentration method for carbonate ores. Thermal decomposition in this method, so cyanide is not used, it is the ore or the oxide of the metal is heated alone to decompose it. So now let us see the next question, 11th one. The ore which is not concentrated by electromagnetic separation is. See the once again question. The ore which is not concentrated by electromagnetic separation. So the options are cassiterite, chromite, magnetite, cornellite. So here 4 ores are given. So see which one is magnetic in nature and which one is non-magnetic in nature. Then only we select the suitable answer. So but in a question not concentrated by electromagnetic separation is given. So see the first one, cassiterite. So cassiterite is a ore of tin. It contains magnetic impurity wolframite. Its formula is FeWO4. So chromite ore itself is a magnetic in nature. FeCr2O3, that is magnetic in nature. The next one is magnetite. The composition of magnetite is Fe3O4. So it is also magnetic in nature. The last one, cornellite, its composition is KCl.MgCl2.6H2O. So it is non-magnetic and hence it is not concentrated by electromagnetic separation. Therefore, option is D. Let us see the next question, 12th one. The main reactions occurring in blast furnace during the extraction of iron from hematite ore are given as the option 1, Fe2O3 plus 3CO giving rise to 2Fe plus 3CO2. The second option is FeO plus SiO2 giving rise to FeSiO3. The third option is Fe2O3 plus 3C giving rise to 2Fe plus 3CO. The fourth option is CaO plus SiO2 giving rise to CaSiO3. So, in the question they have asked the main reactions occurring in the blast furnace during the extraction of iron from hematite ore. So, in the extraction of iron, the concentrated ore mixed to coke and limestone, and it is taken in a reverberatory furnace heated in a hot blast of air. So, in the reverberatory furnace or blast furnace, several reactions are taking place in different zones. So, the first zone is a zone of reduction. In this zone, so iron oxide is reduced to iron metal. So, using a carbon monoxide. This is because carbon monoxide acts as a reducing agent below 923 Kelvin. It is lower temperature zone. So, in the next zone, slag formation zone, in this zone, so two reactions are taking place. The first reaction is CaCO3 decomposed to CaO and CO2. CaCO3 on heating alone giving rise to CaO plus CO2. So, the CaO acts as a basic flux, combines with SiO2 giving rise to CaSiO3. So, this is also a reaction taking place in the blast furnace. And also the first reaction Fe2O3 plus 3CO, that is carbon monoxide, reduces iron oxide to iron at low temperature. Hence, it gives 2Fe plus 3CO2. The next reaction reaction C, in this reaction occur in the extraction of the wrought iron. Therefore, it is not taking place in the extraction of iron from hematite. Therefore, options are A and D. So, suitable options are A and D. Now, let us see the next question, 13th question. Choose the correct option of temperature at which carbon reduces FeO to iron and produces CO. So, options are below temperature at point A, option B approximately at the temperature corresponding to point A, option C above temperature at point A but below temperature point. Next one D, above temperature at a point D. So, let us see the graph for this question. So, Helium diagrams are nothing but plots formed by plotting standard free energy change along y axis and temperature along x axis. So, temperature ಅನ್ನು x axis ಅಲ್ಲಿ ಪ್ಲಾಟ್ ಮಾಡಬೇಕು, ಸ್ಟ್ಯಾಂಡರ್ಡ್ ಫ್ರೀ ಎನರ್ಜಿ ಚೇಂಜ್ ಅನ್ನು y axis ಅಲ್ಲಿ ಪ್ಲಾಟ್ ಮಾಡಿದಾಗ ಡಿಫರೆಂಟ್ ಗ್ರಾಫ್ಸ್ ಬರ್ತವೆ. ಈ ಗ್ರಾಫ್ಸ್ ನಾವು ಎಲಿಂಗ್ಯಾಮ್ ಡಯಾಗ್ರಾಮ್ಸ್ ಅಂತ ಕರಿತೀವಿ. ಸೊ, ಇದರಲ್ಲಿ ಒಂದು ಕ್ವಶನ್ ಅನ್ನು ಕೊಟ್ಟಿದ್ದಾರೆ. ಲೆಟ್ ಅಸ್ ಸಿ. ಸೊ, ದ ಫಸ್ಟ್ ಲೈನ್ corresponds to C plus O2 giving rise to CO2. The next line corresponds to 2C plus O2 giving rise to 2CO. The next line corresponds to 2CO plus O2 giving rise to 2CO2. The last one is Fe. The third line is Fe plus O2 giving rise to 2FeO. So, here is a point. This point is called A. So, it is an intersection point. The last flat is given like this. 2CO plus O2 giving rise to 2CO2. So, the point B is here, the point E is here, and the point D is here. So, in the questions, choose the correct option of temperature at which carbon reduces, that is coke reduces FeO2 iron and produces carbon monoxide. So, the main features of Helium diagrams are, the first point, the graph which is having a lower standard enthalpy of free change is more stable and reduces the metal present above it. So, therefore, here the option is below temperature at point A. Let us say below temperature. So, in this point A, the formation of 2CO from 2C plus O2 is above the graph of iron, therefore, so this is not possible. The first option is not possible because the standard enthalpy of formation of CO is more than the standard enthalpy of formation of the iron oxide. Hence, option A is not correct. Now, let us see approximately at the temperature corresponding to point A. So, approximately. So, here, so which one is that is carbon reduces iron oxide to iron. So, at this point, so they are intersecting. Therefore, the standard free energy chain is same. Therefore, this option is also not possible. Let us see the next option, above temperature at point A, but below temperature at point A. So, let us see this one, above the temperature at point A, above means this one, above temperature. So, at this temperature, so the standard enthalpy of formation of CO is less than the standard enthalpy of formation of FeO. Hence, the iron oxide is reduced by carbon monoxide. So, next one, last one is above temperature at point D, above temperature, this one is, this is the point D. At this point, see this curve, another curve is there, CO intersects the iron oxide line. Below this temperature, so CO acts as a reducing agent for iron, hence the option D is correct. Above temperature, point at D, above temperature, right? Option D is correct. Now, let us see the next question. In the extraction of copper from sulfide ore, the metal is formed by the reduction of Cu2O with. So, usually copper metal is extracted from copper pyrites. First it is roasted, then the roasted mixture is taken in a converter along with SiO2 and heated. So, therefore, the options for this one is given as FeS, CO, Cu2S and SO2. Let us see the reaction, and also before going to reaction, see the question. In the extraction of copper from sulfide ore, the metal is formed by the reduction of Cu2O with. So, here FeS oxidized to FeO, FeO combines with SiO2 giving rise to FeSiO3. Therefore, this option is not correct to reduce Cu2O to Cu. The next one is carbon monoxide. So, carbon monoxide is not used as a reducing agent in the extraction of copper. The next one is Cu2S. So, Cu2S is combines with Cu2O, gives copper metal and sulfur dioxide. So, this is called auto reduction or self reduction. In self reduction, so metal oxide Cu2O reduces with Cu2S to blister copper. Blister copper means during its cooling, sulfur dioxide comes out as bubbles or blisters, hence it is called blister copper. Therefore, option B is not correct, hence option C is correct. But SO2 is a gas liberated in self reduction of the copper oxide and copper sulfide. Therefore, option C is correct in this one. Now, let us see the next question, 15th question. When copper ore is mixed with silica in a reverberatory furnace, copper matte is produced. The copper matte contains 4 options are given. The first one is sulfides of copper 2 and iron 2. Second option, sulfides of copper 2 and iron 3, sulfides of copper 1 and iron 2. The last one option, sulfides of copper 1 and iron 3. So, in the extraction of copper, silica is mixed to remove the impurities FeO present in the molten copper. So, after that copper matte is obtained. Copper matte is a mixture of Cu2S and FeS, copper sulfide and ferrous sulfide. So, by finding the oxidation state of copper in the first one and in the second, we can say the correct option for this question. So, in this option 2Cu, the oxidation state of S is minus 2 is equal to 0. Therefore, 2Cu is equal to 2, Cu is equal to 2 by 2 is equal to plus 1. The oxidation state of copper in Cu2S is 1. So, that is copper 1 ಆಯಿತು. The next one is find out the oxidation state of Fe. We need Fe, that is iron, in ferrous sulfide. So, which is equal to 0. So, we have to find oxidation state of Fe, put as it is Fe, and oxidation state of sulfur is minus 2, it is equated to 0. Therefore, Fe is equal to plus into minus minus 2, the transfer this minus 2 right hand side, then you will get plus 2. So, iron is present here in plus 2 state. Therefore, copper 1, sulfide of copper 1 and iron, the oxidation state of iron 2. Therefore, the option is C, sulfides of copper 1 and iron 2 is the correct option for the above question. So, now let us see the next question, the 16th question. The slag obtained during the extraction of copper from copper pyrites is composed of. So, copper anna copper pyrites ninda extract ಮಾಡಬೇಕಾದಾಗ ಬರ್ತಕ್ಕಂಥ ಸ್ಲ್ಯಾಗ್ ಯಾವುದು ಅನ್ನೋದನ್ನು ಇಲ್ಲಿ ಕೇಳಿದ್ದಾರೆ. So, let us see the options. The 4 options are Cu2S, first one, the second one CuSiO3, the third one FeSiO3, the last one CaSiO3. So, during the extraction of copper from copper pyrites, the first step is roasting of copper pyrites, that is Cu, Fe, S2. So, this on roasting in excess of oxygen, this is converted into Cu2 S plus Fes plus sulfur dioxide. So, actually this is the reaction, it is not balanced here. So, Cu2S So, again combines with O2 giving rise to Cu2O and SO2. FeS also oxidized by air giving rise to FeO plus SO2. So, Cu2O combines with unconverted Cu2S, undergoes auto reduction giving rise to molten copper. So, ಇದನ್ನು ಈಗಾಗಲೇ ಇಂದಿನ ಕ್ವಶನ್ ಅಲ್ಲಿ ಹೇಳಿದ್ದೀನಿ. So, but the FeS is oxidized to FeO. This FeO combines with the slag, impurity, that is flux, acidic flux SiO2 giving rise to FeSiO3. So, therefore, the slag formed in the extraction of molten copper is FeSiO3, that is C. Because FeO is the basic impurity in the extraction of copper, therefore, combines with acidic flux SiO2 gives FeSiO3, that is FeO plus SiO2 giving rise to FeSiO3. The correct option is C. Now, let us see the next question, 17th question. The process used for purification of Al2O3.2H2O is Al2O3.2H2O is a chief ore of bauxite. So, bauxite ore is a purification. Here they are asked purification method, the process used for purification of bauxite. 4 options given here are: the first one is magnetic separation, the second one is leaching, the third one is froth flotation, the fourth one is electro refining. Let us see one by one. Magnetic separation method is the concentration method used to concentrate the ores containing magnetic materials. The second method is leaching method. So, this is a special method used to purify the bauxite ore. So, in leaching method, the ore is dissolved in sodium hydroxide, aqueous solution of strong sodium hydroxide. So, at temperature, so 473 to 523 Kelvin under a pressure of 35 to 36 bar. At these conditions, bauxite dissolves in sodium hydroxide giving rise to sodium meta-aluminate. So, hence the bauxite is purified by leaching method. So, let us see other options are not correct for this one. Froth flotation. This is used for the concentration of sulfide ores. So, here Al2O3 2H2O is not a sulfide ore, hence third option is not correct. The last one is electro refining. So, refining method is used for the purification of molten metals. Hence the D is not also correct, hence the correct option is B. So, right, now let us see the next one. Next question. So, 18th questions. In the Bayer's process, options are given. Al2O3 goes into solution as soluble aluminum hydroxide ion, but impurities TiO2 and Fe2O3 remain insoluble. Third option, Al2O3 is insoluble in NaOH solution. C, Al2O3 changes to aluminum nitrate. D, none of the above. So, here the first option is given. Al2O3 goes into solution as soluble AlOH4 ion. So, now let us see Bayer's process. So, in Bayer's process is used to purify the ore of aluminum, that is bauxite, Al2O3.2H2. So, in Bayer's method, the concentrated ore is leached with strong aqueous solution of sodium hydroxide under high pressure and at high temperature. It also contains impurities SiO2, TiO2, Fe2O3. On treating the bauxite ore with a strong solution of sodium hydroxide, alumina, that is Al2O3, dissolves, giving sodium metaaluminate, NaAlOH 4 times. So, from NaAlOH 4 times, the pure alumina is obtained. So, therefore, option A is correct. Al2O3 goes into solution as soluble aluminum hydroxide ion, but impurities TiO2 and Fe2O3 remain insoluble. So, let us see the next option. Al2O3 is insoluble in NaOH solution. So, usually Al2O3 alone is a bad conductor and has high melting point, hence it is insoluble in NaOH. The next one method is a Surpass method. So, in this method, alumina, coke and nitrogen on heating gives aluminum nitrate plus carbon monoxide. This process is called Surpass process. So, this on digested with water gives aluminum hydroxide. On ignition gives pure alumina. So, but this not contains the impurities TiO2, Fe2O3, etc. Hence, this option is also not correct. Therefore, the correct option is A. Now, let us see the next one. In the electrolytic method of obtaining aluminum from purified bauxite, cryolite is added to the charge in order to. So, cryolite and fluorspar is added to purified alumina. This is because to lower the melting point of alumina and increase its conduction. So, this method is called Hall-Héroult method. So, therefore, the option is in the presence of cryolite which forms melt with lowering melting point of alumina. Hence, option B is correct. The first option, it is used to prevent loss of heat due to radiation. Next one, C, in this method, cryolite not increases the melting point. Next one, D, to prevent carbon electrodes, cryolite is not used. Hence, option is B. Now, let us see the next question, 20th question. In electrolysis of Al2O3 by Hall-Héroult process, let us see the following option, which one is correct. Cryolite Na3AlF6 lowers the melting point and increases its electrical conductivity. Second option, Al is obtained at cathode and carbon dioxide at anode. C, both A and B are correct. D, increases the melting point. So, cryolite is added in Hall-Héroult process to purified alumina to lowers the melting point and increases the electrical conductivity. So, this is because cryolite has high melting point and also bad conductor. Therefore, the option A is correct. The next one is aluminum is obtained at cathode and carbon dioxide at anode. So, this is reverse. Aluminum usually obtained at cathode and carbon dioxide is at anode. The next, both A and B are correct. So, option C is correct. Option C, both A and B are correct. Hence, option C is the correct here. The last option is not correct because cryolite not increases the melting point of alumina. Next one, 21st question, zone refining is based on a principle of. So, zone refining is used to obtain ultra pure metals, silicon and germanium. So, this method is based on impurities of low boiling metals can be separated by distillation. The second option, impurities are more soluble in molten metal than in solid metal. C, different components of a mixture are differently adsorbed on a adsorbent. D, vapor of volatile compound can be decomposed to pure metal. So, here zone refining. So, in this method, the impurities are more soluble in molten metal than in solid metal. This is the principle present in zone refining. So, other options are not correct. So, the first option is used to obtain zinc, cadmium and mercury. The third option is based on chromatography. The last option is based on vapor phase refining. Therefore, the option B is correct. So, next one, 22nd question, formation of nickel tetracarbonyl and its subsequent decomposition into nickel and carbon monoxide makes the basis of Mann's process. The reaction is Ni plus 4CO T1, NiCO 4 times, again temperature T2 gives nickel plus 4CO, T1 and T2 are. So, in Mann's process, pure nickel is obtained. First of all, the impure nickel is heated at lower temperature T1 and the complex formed is decomposed by heating to higher temperature. So, the lower temperature T1 is 50 degree centigrade and T2 is at 230 degree centigrade. Let us convert them into Kelvin temperature. So, 50 degree centigrade is converted to Kelvin temperature by adding 273 Kelvin. So, which is equal to 323 Kelvin. Here we can write in Kelvin as 323. The next temperature is higher temperature 230 plus 273 giving rise to 30503 Kelvin. So, the higher temperature is 503 Kelvin. So, next one, 23rd question, Van Orkel method of purification of metal involves converting the metal to a, 4 options are given, volatile stable compound, volatile unstable compound, non-volatile stable compound, D, none of the above. So, here Van Orkel method. Van Orkel method is based on vapor phase refining. Vapor phase. So, the principle in vapor phase refining is, so the first principle, the impure metal or crude metal is converted into a volatile compound by heating to lower temperature. The volatile compound is decomposed into pure metal by heating to high temperature. So, the volatile compound, whichever is formed in the first step, is stable, little bit stable. Therefore, the option is A, volatile stable compound. So, now let us see the next one. Sodium, magnesium and aluminum can be obtained from their ore by 4 options. The first one is electrometallurgy, C, hydrometallurgy, B, pyrometallurgy, D, smelting. So, let us see one by one. Electrometallurgy is used to extract metals by the electrolysis of salt solutions using anode and cathode. So, the next one is pyrometallurgy. It is the process of obtaining impure metals by heating to high temperature using suitable reducing agent. The third one is hydrometallurgy. So, it is a process of dissolving ore in a suitable chemical reagent and by precipitation using more active metals, gold and silver, low grade copper, etc. are obtained by this method. Smelting. So, it is a process used to obtain crude metals at high temperature. So, therefore, option here, fused metals, their ore by, obtained from their ore by electrometallurgy. This is because sodium, magnesium and aluminum are strong electropositive metals. Generally, electropositive metals are obtained by electrometallurgy. So, using anode and cathode, hence option is A. Now, let us see the next one, 25th question. Which element of group 15 of the periodic table is a typical metal? So, the metallic property of the elements in each group from top to bottom increases as their atomic size increases. So, here 15th group is given. In 15th group, 5 elements were present. The first one is nitrogen, the second one is phosphorus, next one is antimony, and bismuth. Stibm is also there, but it is not in this option. Hence, so first element is nitrogen, second element is phosphorus, third element is antimony. Nitrogen and phosphorus are typical non-metals. They are typical non-metals because of their high electronegativity. So here antimony is a metalloid. So its properties are similar to metal as well as non-metal. Hence, the actual metal in this group is bismuth. So it has a large size. Hence, bismuth is the correct option. So bismuth, option D. It is not antimony. Option D is correct. Option D, bismuth. Now let us see which of the following element is least electronegative in group 15 elements. So in the same group, electronegativity from nitrogen to bismuth decreases as the size of the atom increases. So the 15 group elements are arranged like this. So the first element nitrogen, phosphorus. So the next one is here antimony, arsenic, and so bismuth. So here they are given 4 elements. Nitrogen is given, then arsenic is given, antimony is given, and bismuth is given. So therefore, least electronegative element. The least electronegative element again here is bismuth. So other elements have more electronegative than bismuth. Let us see the next one. Select the correct statement about order of stability of oxidation states. The first option is bismuth 3 plus is greater than Sb 3 plus is greater than As 3 plus. Second option, As 3 plus is greater than Sb 3 plus is greater than Bi 3 plus. C, Sb 3 plus is greater than As 3 plus is greater than Bi 3 plus. D, Bi 5 plus is greater than Sb 5 plus is greater than As 5 plus. So in the same group, these elements are present in the same group. Therefore, oxidation state increases from top to bottom generally, but due to inert pair effect, the stability of the first ply oxidation state decreases down the group and stability of +3 oxidation state increases. So see this point. Due to inert pair effect, stability of +5 oxidation state decreases down the group and stability of +3 oxidation state increases. So therefore, +3 is more stable than the +5 oxidation state. Therefore, the option is Bi 3 plus is more stable than Sb 3 plus is more stable than As 3 plus. So remaining options are not correct. So because of inert pair effect. So let us see the next one, 28th question. Boiling point of ammonia is greater than pH 3 phosphine due to the first option, small size of nitrogen. Second option, large size of phosphorus. C, presence of intermolecular hydrogen bonding. D, higher electronegativity of nitrogen than phosphorus. So generally boiling point depends on hydrogen bonding. The second one is their atomic size. So here hydrogen bonding, strong intermolecular hydrogen bonding present between ammonia molecules. Therefore, the boiling point of ammonia is greater than the boiling point of pH 3 phosphine. Hence, the option C is correct. So what about in phosphine? In phosphine, so there is a very weak intermolecular hydrogen bonding is present. Therefore, the boiling point of ammonia is more than the boiling point of phosphine due to intermolecular hydrogen bonding. 29th question. Among the following oxides of nitrogen, which is the most acidic in nature? So 4 options, N2O, N2O3, N2O4, N2O5. So in the synopsis, I already give an hint regarding this one. So, let us calculate the oxidation state of nitrogen in all these oxides. In the first one, I will show for the first one, N2, we know the oxidation state of N2, therefore, write it as 2N plus O is equal to 0. 2N, oxidation state of oxygen is minus 2 is equal to 0. Therefore, 2N minus 2 is equal to 0. Therefore, 2N is equal to plus 2. Therefore, N is equal to plus 2 by 2 is equal to plus 1. In the first one, our first option, oxidation state of N2 is plus 1. In the second one, oxidation state is plus 2. In the third one, oxidation state is plus 4. Plus 4. In the D, oxidation state is plus 5. As the oxidation state of the element in their oxide increases, their acidic strength is also increases. So, therefore, the option is D, because nitrogen has highest oxidation state in its oxide. Now, let us see the next question. This question is on bond dissociation enthalpy. So, the bond dissociation enthalpy of E bond H, E means element, H is equal to hydrogen, bonds is given below. Which of the compounds will act as strongest reducing agent? The compound are ammonia, PH3, ASH3 and SbH3, and EH dissociation enthalpy is also given 389, 322, 297, 255. So, the options are A ammonia, C ASH3, B PH3, D SbH3. So, let us see the molecule in which EH bond dissociation enthalpy is lower, that molecule acts as a strong reducing agent. By observing the dissociation enthalpy of EH among these four molecules, SbH3 has lowest bond dissociation enthalpy, that is 255 kilojoule per mole, hence it acts as strongest reducing agent. And also size of the atom increases from nitrogen to CBM. As a result, the bond dissociation enthalpy decreases. Therefore, the option is SbH3. Let us see the next question. Which of the following elements does not show allotropy? So, allotropy means a same element present in a different elemental forms. So, usually nitrogen shows allotropy, carbon shows allotropy. So, here the nitrogen family is given. The first option is nitrogen, the second option is bismuth, the third option is antimony, the fourth option is arsenic. So, here the bismuth is the last element present in the 15th group. It is purely metallic. Therefore, so option is B. Why the other options are not correct? See that one. Nitrogen has 3 allotropic forms, 2 solid and 1 gaseous state. Antimony has 2 allotropic forms, yellow and black, and arsenic has 3 allotropic forms, gray, yellow and black. But so bismuth has no allotropic form, hence the correct option is B. 32nd question. In case of nitrogen, NCl3 is possible but not NCl5, while in case of phosphorus, PCl3 and PCl5 are possible, is due to. Let us see the options. The first option, availability of vacant d orbitals in P but not in N. B, lower electronegativity of P than N. C, lower tendency of hydrogen bond formation in P than N. D, occurrence of P in solid state while N in gaseous state at room temperature. So, here the formation of molecules from nitrogen and phosphorus are given. So, the formation of molecules depends upon the overlapping of orbitals and also the availability of orbitals. So, in nitrogen, so valence shell electronic configuration is given. It is 2s2 2p3. Totally 4 orbitals are available, that is 1s, that is 2s 1 orbital, and p, that is 2p 3 orbitals. Total number of orbitals available for bonding is 4, but the 2s orbital is not generally involved in bond formation, hence only 2p 3 orbitals are available. So that means it has no d orbital, it has no d orbitals, therefore it forms NCl3 by using 3 2p orbitals, but not NCl5. But in phosphorus, let us see the valence shell configuration. Its valence shell configuration is 3s2 3p3, but also there is a 3d orbital near to 3p, hence one electron from 3s orbital jump to 3d. Therefore the number of orbitals available for bond formation are 1 3s, so 3 2p and 1 3d. So therefore total number of orbitals available for bonding is 5, hence PCl5 forms phosphorus forms PCl3 and also PCl5 by utilizing 3 3p orbitals and 1 3s, 3p and 1 3d orbitals. So therefore the correct option is A, availability of vacant d orbitals in phosphorus, not in nitrogen. 33rd question. Dinitrogen is prepared by the decomposition of the following compounds. Options are: the first option ammonium nitrate, second option ammonium dichromate, third option sodium or barium oxide, all the above. So let us see the first one, ammonium nitrate. Formula is NH4NO2. On heating it gives N2 plus 2H2O. So here nitrogen is formed, that is dinitrogen. The next one is ammonium dichromate. So on heating ammonium dichromate, we also get nitrogen, water, chromic oxide. Similar third one, sodium oxide. Formula is 2NaN3. On heating it gives N2. So see all these. The fourth one, barium oxide, on heating gives barium and dinitrogen. So in all these compounds, nitrogen is formed. Therefore the answer is D, all the above. Let us see 34th question. Nitric oxide is paramagnetic in nature. The options are gaseous state, liquid state, solid state, polymeric state. So the substances are broadly classified into 3 types. The first one is a paramagnetic substance. The second one is diamagnetic substance. The third one is a ferromagnetic substances. So ferro. There are 2 more types, ferrimagnetic and antiferrimagnetic. Let us see what is diamagnetic substance. A substance which is not attracted by the magnetic field is called diamagnetic. So this is due to absence of unpaired electrons. So a compound or a molecule not having a unpaired electron or single electron or odd electron is not attracted by the magnetic field, hence they are called diamagnetic substances. So paramagnetic substances are those which are attracted weakly by the magnetic field due to the presence of 1 or 2 electrons. The last one is ferromagnetic substances. These are strongly attracted by the magnetic field and retains magnetic property even after the magnet is removed or magnetic field is removed. Means they are converted into permanent magnets. So here the question is nitric oxide is paramagnetic in nature. So in gaseous state, liquid state, solid state, polymeric state. So it is only in gaseous state it is paramagnetic. This is because of presence of 1 odd electron. So calculate the number of electrons present in the nitric oxide, that is here. So, in nitrogen the formula is NO, nitrogen has 7 electrons, oxygen has 8 electrons, total number of electrons are 15. On grouping into 2 we get, so 7 electrons, paired electrons, 1 odd electron. Due to the presence of 1 odd electron in gaseous state, it is paramagnetic. So, in liquid and solid state, NO undergoes dimerization, that is NO plus NO, NO plus NO giving rise to N2O, N2O2, dinitrogen dioxide. So, on dimerization the total number of electrons becomes 30. See here, 2 nitrogen atoms. So, it is 7 plus 7, 14, not 15, is 7 plus 7, 14, and oxygen, dioxygen, 8 plus 18 is equal to 16. So, 14 plus 16 is equal to 30 electrons. So, on grouping into 2, it becomes 15 pair of electrons. So, therefore, in liquid and solid state, nitric oxide is diamagnetic. Therefore, the correct option is A. So, let us see the next one. Paramagnetic species are options are A, NO, NO2, O2, B, N2O4, N2O2, O3, option C, NO2, NO plus, NO2 plus, O2 plus, option D, O2, CO, CO2. So, paramagnetic nature of the molecules are decided by presence of odd number of electrons. That is, when 1 electron is present, then they are called paramagnetic substances, or 2 unpaired electrons or 3 unpaired electrons are present in the species, then they are called paramagnetic substances. So, let us see in the first option NO, NO2, O2. So, NO 7 plus 8 is equal to 15 electrons in first option A. So, NO2 7 plus 16. So, 2 oxygen atoms are there. Each oxygen atom has 8 electrons. 8 plus 8 is equal to 16. 16 plus 7 is equal to 23 electrons. So, this is also 1 odd electron or 1 electron. This is also 1 electron. So, oxygen has 2, although it has 16 electrons, 2 electrons are unpaired. So, this can be known by drawing molecular energy level diagram. Molecular energy level diagram ಅನ್ನು ಇದಕ್ಕೆ ಬರೆದಾಗ, ಸೊ ಆಕ್ಸಿಜನ್ ಡೈಆಕ್ಸಿಜನ್ ಅಲ್ಲಿ 2 unpaired electrons ಇರ್ತವೆ. Hence option is correct option. Let us see in case of the second one. In second, third and fourth option, so some of the species are not paramagnetic. Therefore, the correct option is the first option. Now, let us see the next one. Next question, 36th question. So, the wrong statement about N2O is nitrous oxide is first option known as laughing gas. B, it is not a linear molecule. C, it is a neutral oxide. D, its structure is similar to CO2. So, let us see the question, the wrong statement, not the correct statement. So, we know that nitrous oxide is a laughing gas. When we take some amount of nitrous oxide, or when we go to the atmosphere of nitrous oxide, so laughing will takes place. This is due to the effect on the nervous system. So, therefore, the correct option is first option is correct. The second one is it is not a linear molecule. Nitrous oxide is a linear molecule. So, means all the atoms are present in the straight line. The second one is third one is it is a neutral oxide. Nitrous oxide is neutral, it is neither acidic nor basic. So, last one is structure is similar to CO2. So CO2 structure is written like this, C double bond O, C double bond O. Similarly, N2O is written like this. Hence, the correct option is, it is not a linear molecule. It is a linear molecule. The wrong statement here is, it is not a linear molecule. Now let us see the 37th question. The oxides of nitrogen which undergoes dimerization. So dimerization means so two molecules combining with each other to give one molecule. This process takes place when a species or a molecule has one unpaired electron or odd electron. So options here are N2O, NO. So N2O not undergoes dimerization because it has so 7 plus 7 14 plus 8 22 electrons are there, but NO undergoes dimerization. So hence it is not a correct option. The next one is NO and NO2. So here NO has one odd electron and also NO2 has one odd electron. So hence these two molecules undergoes dimerization. So similarly, on calculating the number of electrons in N2O5 and N2O3, also in D, N2O5 and NO2, these are also not having odd number of electrons. Hence, so B is the correct option. Those two undergoes dimerization. Now let us see the next slide. The anhydride oxide of nitrogen or anhydride oxygen of nitrogen or options are N2O5, NO2, B, NO, NO2, C, N2O5, N2O, D, N2O5 and NO. So here some equations are given here. So let us see N2O3 plus H2O giving rise to 2HNO3. Therefore, N2O3 is anhydride of nitrous acid. Similarly, NO2 is an anhydride of the nitrous acid and nitric acid. The last one, N2O5, is an anhydride of nitric acid. So the anhydride of nitric acid nitrogen are N2O3, NO2 and N2O5. So let us see that pair, which one contains these. So the first option is N2O5 and NO2. Both are anhydride oxygen of nitrogen. In second one, NO2 is anhydride but not NO. In the third one, N2O5 is anhydride, not N2O. In the fourth one, N2O5 is anhydride, NO is not anhydride. Therefore, the correct option is A, N2O5 and NO. 39th question. Solid N2O5 exists in ionic form. The formula is. So here the solid N2O5 exists in ionic form. The formula is. So N2O5 on splitting, it gives NO2 plus and NO3 minus. So therefore the option is A, NO2 plus and NO3 minus. Okay. So by this I will end of this session. So I think you are using this synopsis and questions what I discussed in this session, which are more useful for your CET and NEET classes. So on the idea given in this one, you make use these ideas and answer more number of questions in this chapter. So thank you for Department of Pre-University Education, so giving an opportunity to discuss some questions on general principles and group 15 elements. Thank you.